Hi, Dr. Jagriti.
Good evening,
Can you
sir.
hear me?
Yes, sir. Hello, good evening, sir. I hope I'm audible.
Hello.
Good evening, sir.
Good evening. We can start the session now.
Sure, sir. Good evening, everyone. I welcome you all to the last day of our workshop. And today we have among us Honorable Dr. Fulin Sharma, Assistant Professor, Department of Pharmacology, AIMS, Guwahati. I take privilege to introduce you all to Dr. Fulin. He is a distinguished professional in the field of clinical pharmacology with an illustrious academic and professional trajectory. A graduate of Assam Medical College, where they earned both their MBBS and MD in pharmacology. They further on their expertise by completing a postgraduate diploma in the clinical research while completing his DM in clinical pharmacology from PGI-MER, Chandigarh. Dr. Fulin has held a pivotal role, starting as a medical officer in Assam, progressing to positions such as Senior Resident PGI-MER Chandigarh, and currently serving as an assistant professor in pharmacology at AIMS Guwahati since 2022. An accomplished researcher, they boast an impressive portfolio of over 150 publications with 109 PubMed indexed articles and an H-index of 31, reflecting their significant impact in the academic community. Adding to their credentials, Dr. Fulin Sharma has applied for 4 patents, with 1 granted, highlighting innovations in the antimicrobial sector and medical devices. Their career exemplifies a dedication to advancing medical research and education. We welcome you, sir, to enlighten the participants with your expertise on the topic risk of bias in quality assessment of included studies for SRMA on the last day of this workshop. Over to you, sir.
Can I share my screen? Very thank. First, I am very thankful to Dr. Jitendra Gorla, Dr. Jagriti Saini, IMBSS, and whole the teams for giving me this opportunity. And so now I would like to start my presentation. So can I share my screen?
Sure, sir, you can share.
Okay. Is it visible?
Yes, sir, it is visible.
Okay. So my topic of presentation today is data extraction quality assessment. So I will be covering the planning is like objectives. So describe tips for data extraction, like developing the form, extracting the data, entering the data, then entering the data, then discussion on the risk of bias, then describe the quality assessment of randomized control trials, which I will be covering in a detailed way. Then describe quality of studies in observational studies that I will be covering partially. So what data we are interested in meta-analysis? So basically for data extraction, we are data means like we are basically interested for meta-analysis purpose. So data can be either a constant.
Sorry to interrupt you, sir. Actually, your slides are not moving.
Okay.
Maybe slideshow is not activated on screen. We can see your third slide right now, sir, but maybe slideshow is not activated.
No, I am only on the third slide only.
It just moved, yes, sir. Sir, can you please just move second and fourth so that we can verify it is working on our screen?
Is this on second coming?
No, sir, it is on third only.
Okay. Okay, so I am sending you the PPT. Please do it for me. Okay.
Okay, okay, sir.
I have sent to Dr. Jitendra.
Okay, sir, please give me a minute. I'll just try to coordinate it further. Sir, he has not yet received PPT. Have you shared it via email or WhatsApp?
I can share it by WhatsApp also.
Okay, sir, thank you very much.
जीतू का मैं आपको I have sent to Dr. Jitendra via WhatsApp also. Okay.
Okay, sir, I'll just coordinate again. Sorry for keeping you in wait state, sir. I've just received PPT and I'm sharing it now.
Okay. Thank you. Okay, can I start?
Yes, sir, you can start now.
Can I share the slides from my end also?
I think, sir, it will be shared from here only now.
Okay. Okay. So basically you will be changing the slides, is not it?
Yes, so you can just let me know when you need me to shift to the next slide.
Okay, sure. So next slide. So this slide is already covered. So these are the data. What are the data that are we mainly extract for meta-analysis, like methods, like participants? What are the participants? Is they fulfilling or inclusion exclusion criteria or not? So basically this forms the PICO. So what is about population, about the interventions, about the comparator, or the outcome, or it can be PIROT, that is population, index test, reference test, then outcome, etc. and timelines. So as per the requirement of the study, we will extract data. That can be the methods, that can be the participants, that can be the settings. Which setting? Because many times you will be interested in some subgroup analysis like hospital setting versus community-based setting. Many times interventions, because details of intervention is very, very important. Like, let it be somebody is using stem cell only, but the characterization of stem cell may be hugely vary among different studies. So how much your stem cell is being administered, or how much your drug amount is being administered, that may significantly vary, and owing to the dose response curve which may exist in the above cases. So on that basis, what happens? There can be significant variation in the effect size of your outcomes, and which can lead to your significant heterogeneity among the included studies. So then outcomes. So is that a direct outcome or a indirect outcome? Because direct outcome or indirect outcome, so indirectly representing the outcome. So those things will have lots of impact upon your grade methodology, that have strong, very important your impact upon the grade methodology. So what are the results? What are the publications? Is there any difference between the published protocol and the result, and the published your outcome or published your paper? So what is the difference between the reported results among your published your protocol or published your research paper? Is there any difference? So who are the investigators? What is the funding source? Next slide, please. Next slide, please.
Yes, sir.
So checklist. So this is a very simple checklist of data elements, like source, that is study ID, citation, author, email, etc. Because many times we may have to ask the author for your data, for providing us the data. This specifically happens in case of many of the it happens with all kind of studies, but specifically in time to event data, where actually what happens, where individual IPD meta-analysis or individual patient data meta-analysis is preferred many times, because otherwise the O minus E or variance, those all are derived. So so this is very, very important. And eligibility, confirm eligibility. If it is excluded, then what is the reason for exclusion? Many times what happens, the reviewers may ask for specific studies, why that study was excluded or why that study was included. So methods, study design, details of the study design you have to note. Then sequence generation method, how the sequence was generated. Then allocation sequence concealment, the randomized sequence that was generated, how that sequence was concealed, or allocation sequence was concealed. Then blinding. So participants total number, that is very, very important in case of dichotomous, or in case of your continuous data. You all know that total number, total event we have to incorporate in case of dichotomous versus dichotomous, and out of the total participants. So total number is very, very important. Settings I have already told you. Then diagnostic criteria. Many times what happens, the variation in the study results, or your like heterogeneity among the outcomes, or heterogeneity among the studies, that actually diagnostic criteria may be a cause for the heterogeneous study result. So like, let it be Alzheimer's. So many times Alzheimer's, the definition of Alzheimer's disease that evolved over time from 1980s to 2000s to
20s. So that heterogeneity among the studies may vary, and many times different societies, they give different your or different your diagnostic criteria definitions. So that can add on to the heterogeneity among the included studies. So age, that is also we all know age has implications on multiple things like body physiology, pharmacokinetics, ADME. So it impacts all of those absorption, distribution, metabolism, and excretion. So then sex difference is there. Then results. So what is the sample size? Missing participant, that is very, very important. How many were randomized and how many were finally analyzed? Then summary data for each of the intervention group. Let it be 2x2 table or dichotomous data. Next slide, please. So why use a data extraction form? So data extraction form is the form which links what is reported by the investigators in paper and reports to the reports and the systematic reviewer. So that is a basically source or connecting source between the study, what is the reported by the investigator, and the systematic reviewer. So it links the review question and the criteria for such selection, records the many decisions that occur throughout the data collection analysis process. So provides the data for inclusion in an analysis. So next slide. So it can be paper or it can be electronic. So paper, that is convenience or preference. Extraction can be done almost everywhere. Easy to create and implement, easy to compare among different reviewers, and provides record of all changes. Electronic, so convenience or preference, the combines data extraction and data entry into one step. Data from the reviews involves large number of studies that are easily stored, sorted, and retrieved. So, and this is environment friendly. So each of these have their own advantages, own disadvantages. So that depends upon how the systematic reviewer he is comfortable. There is no hard and fast rule, but that depends upon your how the systematic reviewer is comfortable. Next slide. So tips for designing data extraction form, like include the review title, record the names, initials of the person completing the form, include unique ID, then use tick boxes or coded responses. You include yes, no, or not reported or unclear, like this. So use always collect sample sizes when collecting outcome data. In addition to collecting the initial numbers, so that like randomized numbers, and leave a plenty of space for notes. This is very, very important, because once we go through the review process, once we are collecting the data, we have lots of queries. Like many times, this is very, very important in case of your time to event data. In other type of data also very, very important, because somebody will say that only 22% survived. Somebody will say that hazard ratio is this much. So, but all the details you will not get. So how you derive the data or how you got the data, all those records you have to keep, and you have to make, if you go for time to event data, you have to do lots of calculations of the O minus E, observed and that is expected, and variance and all. So those all calculations you have to do. There are softwares also, but you can do manually also. So leave plenty of space for notes. Next slide. So develop and pilot test data collection form, because we cannot make a hard and fast your data extraction form for every scenario, because every study has its own uniqueness, and it is very important to collect or pre-test the data. You have to, it is very, very, we have to do a study specific data collection form. We have to do pre-testing. We have to optimize the form depending upon the feedback from the reviewers. Then we have to retest again. So testing should involve several people extracting data from at least few articles. The initial testing focuses on the clarity and completeness of questions. Users of the form may provide feedback that certain coding instructions are confusing or incomplete. Okay, the testing may identify data that are missing from the form or likely to be superfluous. After initial testing, accuracy of the extracted data should be checked against source document or verified data to identify problematic areas. So we have to test actually. So the areas that need improvement, we have to further modify. It may be necessary to repeat the pilot testing on a new set of reports if major changes are needed after the first pilot test. So we may have to redo the data extraction using the new form. So that may also be required. Next slide. So problems with the data collection form may be surface after pilot testing has been completed, and the form may need to be revised after data extraction has started. When changes are made to the form or coding instructions, it may be necessary to return to reports that have already undergone data extraction. In some situations, it may be necessary to clarify only the coding instructions without modifying the actual form. So the confusions may be in the coding instructions, the confusion may be in the form. We have to do the modification, or we have to optimize the form as per the feedback from the reviewers. Next slide. So this is your example of your data extraction form. Here you can see this is a DTA meta-analysis or DTA review, that is diagnostic test accuracy. So here you can see the ID, then the sub-ID, then author, then title, then year, then language, then industry involvement, then your PTB reference standard, where reference standard was, what was the reference standard. So all this data, what was the setting, last you can see. So all this data you have to use as per the requirement of the study. This is a study on pulmonary tuberculosis, so they have used about the pulmonary therapy. What is the reference standard, like culture, smear, culture and or smear, or bacteriological confirmation. So next slide. So what was the antigen name, antigen details, etc., antigen source, and true positive, false negative, true negative, all those data required for a diagnostic test accuracy review, that was included in this data extraction form. Next slide. So this can be electronic also. Here you can see this is a electronic data extraction form. The same thing, direct smear, you can see TP, FN, FP, TN. So all those 2x2 tables, the information is incorporated in a your electronic way. Next slide, please. Many times what happens, many will prefer extraction of data in Excel format. So this is a format, or this is the data extraction in Excel. Next slide, please. So tips for performing data extraction: provide detailed instructions, process is subjective, base done by 2 independent reviewers. All the data extraction are need to be done by at least 2 independent reviewers. So then resolve disagreements between the reviewers by discussion and or by a third reviewer. Next slide. So once data extraction is complete, enter the data into the database manager, enter only consensus data, that is very, very important. Enter only consensus data, request missing data by emailing to the authors. So many a times the authors will reply you, will not, or they may not reply you also, but you give sufficient time to them so that they can reply you. Ask specific pointed questions. Do not overwhelm the authors with too many questions. Then the chance of getting a response becomes less. Then now comes to the quality assessment of the studies. So what is quality? In the context of systematic reviews, the quality of evidence reflects the extent of confidence that an estimate of effect is correct. So after we have done the meta-analysis, we have come to a certain effect, that this is the effect with this is the point estimate with this 95% of confidence interval. So how much we are confident upon this result? So that actually, this is quality of evidence that reflects the extent of confidence that an estimate of effect is correct. So whatever we got from this meta-analysis, that this is most likely to be attributed to the population. What is the extent that we can believe on this estimate? So that is, quality is one of the very important parameters. Next slide. In the context of making recommendations, the quality of evidence reflects the extent to which our confidence in an estimate of the effect is adequate to support a particular recommendation. Means many of the times the recommendations, or most of the times indeed, the recommendations are based upon your finding from systematic reviews or meta-analysis. So, but if the recommendation is, or if the meta-analysis is done on superfluous studies, then the strength of recommendation will be less, or that will be also flaws. So in the context of making recommendation, the quality of evidence actually reflects the extent to which our confidence upon that recommendation. So that is very, very important. And with grade approach, evidence is graded as high, moderate, low, or very low. Next slide. So bias and variability and definitions. Bias, that is any process at any stage of inference tending to produce result that differ systematically from the two true values. Okay. So variability, that is arises from differences among studies such as population, setting, different definitions of target disorders. So variability may be your that come from, like, maybe the population is different, the setting may be the different among the studies, different definitions of target disorders. So those are your cause of the variabilities. Next question, next slide. So this is hierarchy of evidence and based on study quality. So here you can see expert opinion that has highest your bias, then followed by randomized control trials. Basically randomized, high quality randomized control trials, that is again your less that is less risk of bias. So regarding bias, one thing is important. We don't say this is a bias study. Rather we say there is a high risk of bias. Why? Because we were not present during the study conduct, but rather we are evaluating the study from the published paper, and from there we are trying to infer the amount of risk that is present in the study conduct or during the study. So we are basically trying to assess the risk. So there is high risk or low risk. We never say that high bias or low bias. Next slide. So here you can see for populations of trials examining treatments of myocardial infarction, perinatal medicine and various diseases, it has constantly been shown that inadequate concealment of treatment allocation resulting, for example, from the use of open random number tables is associated on average with larger treatment effect. So high risk of bias, it has its inherent implications that there may be, it has its effect on the effect size, because many times there is reported that high effect size is found. So these are the hazards. Next slide. Next slide. So as in many forms of research, even elegant statistical manipulations, when performed on biased rubble, are incapable of generating unbiased precision stones. So Matthias Eger has put it that the diamond used to represent summary statistic cannot be assumed to be the jewel of the crown. Okay, because it is affected by the quality of the studies. If the quality of the studies that are included are not proper, so it may affect the diamond. Next slide. The quality assessment of systematic reviews of interventions, I am going to describe in details. Next. So this is a screenshot from Rebman. Here you can see on the left side, here you can see data collection and analysis. So under that, what are the selection of studies, data collection and management, assessment of risk of bias in included studies, measures of the treatment effect. So here you can see assessment of risk of bias. You can do itself in a Rebman, but nowadays your ROB2 tool is there. So we make most of us we use ROB2 tool for your risk of bias assessment in your randomized control trial. And I will also discuss for your observational studies that will come. Next slide. So In randomized control trial, the domains to address, that is random sequence generation. So how the randomized sequence was generated, then allocation concealment, how the randomized sequence allocation was concealed, then blinding of participants and personnel. So then blinding of outcome assessment. So that is very, very important. Then incomplete outcome data. So then selective reporting and other bias. So you must consult the handbook before completing your risk of bias assessment. So this is a very important. We can, so one question is there, can we use Ryan software for this? So basically the recommended software is your ROB2 for your risk of bias analysis. Ryan we can use, but Ryan is basically we use for your data abstract data like title and abstract screening, then your full text screening also now that is incorporated. Now Ryan AI is there, which will help you that with specific keywords that this is possibly randomized, non-randomized. So for screening purpose that helps you. But what is recommended for your risk of bias analysis for randomized control trials, that is the ROB2 tool, and Newcastle auto scale is there, and many scales are there indeed. So another question, sir, Redman and which other software? So for risk of bias, we use ROB2. You can, in the internet, you can put the title that is ROB2, ROB2 risk of bias tool. You will get the link how you can download it. Then you should do Marcos enable. Then only you can use the tool in your computer. So now coming to source of bias. So selection. Number one is selection. So random sequence generation. Yes, it is free. You can download it for free. Also, yeah, also you can actually you can download it for free, and also like there is a whole guidance document is there how we can approach for risk of bias assessment. So there are some your signaling questions are there. So from those signalings, yes, I will be showing slide demo. I will be showing. Okay, I will come to that. So selection, random sequence generation. So then that is selection comes under selection of bias, selection bias. Then allocation concealment. Like many times what happened, we made the randomized sequence. Now, so ROB is also for quality assessment of ours. Yes, bilkul. Yes, definitely. So random sequence generation, we can do random sequence generation by using computerized methods. Okay, by using your different your even toss of a coin, etc. So that also different tools are there. Okay, so once the randomization sequence is generated, so how it is, because it has to be how it is, how its concealment is actually allocation is concealed. Okay, so many times we use different methods like snooze or sequentially labeled identical labeled containers, etc. So all those we will discuss in detail. So that comes under selection bias. Next. So random sequence generation occurs at the start of the trial before allocation of participants, avoids selection bias. It determines a random order of assigning people into intervention and control group. So avoid systematic differences between the groups, account for known and unknown confounders. So it is said that randomization balances the confounders between the two groups. Next slide. So what are the low risk sequence generation methods? Like random number table, computer random number generator. So that is, we commonly use this, stratified or block randomization. So many times what happens, why block randomization is required? Because you are doing a clinical trial of 500 participants. And what happened? And 500 participation in each group, let it be. And what happens? You have among the 500 trials, 500 participants in each group, means total 1000. You could enroll only 300 population. Okay, means 300 population you enrolled. Then once, then you wanted to analyze the data because further enrollment was not possible, and you thought that you will do the analysis and you will do publication. But while analyzing, while you see that the decoding of the data, you see that all of the groups were, let it be group A was 280 and group B was 20. So you, in this case, you cannot compare the both the groups because the sample size in group B is very less. So here what, so here, so hence what they do a block randomization. Like let it be, if you have to randomize 1000 population, then we can do 10, block of 10 is means 5A, 5B. But in the block size, 10 block size, we will not know whose is A or which is B. But the software will randomize in such a way that the whole study will be made in, means 1000 population will be made blocks of 10 size is 100 blocks of 10 size, and is 100 blocks will be individually randomized. So at any point of time, let it be we do a analysis at 100. So here we can say that 50 will be your intervention group A, 50 will be group B. Okay. So then minimization, low tech, that is coin toss, shuffling. I will come to the questions one by one because then let's first go with the theory, then we'll come to the practical. So high risk, that is predictable, quasi-random like date of birth, day of visit, ID card record, non-random, choice of clinician or participant, these are your high risk bias. Next slide. Now comes this allocation concealment, occurs at the part of the trial during the allocation of participants about selection bias. When a person is recruited to the study, no one can predict which group they should be allocated to. So it ensures strict implementation of the randomization sequence. So this is a part of random sequence implementation, that is allocation concealment. So prevents changing of the order, prevents your selection of whom to recruit. Okay. Sir, what is that? Sir, can you explain the block randomization again? Okay. So what is block randomization? Maybe let it be you are doing a trial of 1000 population. Okay. So what happened? 1000 population, and that 1000 population will be, you will be dividing into two groups. Not population, 1000 sample. Okay. 1000 sample, you will be dividing the sample into two groups. Okay. So if you do a traditional randomization, you cannot control how which will go to A, which will go to B. It can happen like first initial 400 is in group A, next 300 is in group B. This can happen like this also. Okay. So let it be you could not complete the whole study and you had to stop the study at 400. Then in this case, what will happen? 300 will be group A and 100 will be group B. So both the groups are not equal in sample size. So to avoid this kind of things, so that the study remains balanced at each point of time, okay, number of sample size. So what we can do? We can do your block randomization. Block randomization means the 1000 sample size we can divide into equal size blocks or not equal size blocks, even variable size blocks. That is important in many a case, like variable size blocks. That is very, very important. But I will not go into much of details of that. So let it be, we are dividing the study into a 10 equal size block. Or sorry, 1000 population is there. So is block of 10. So how many blocks will be there? Can you answer it in the chat box? If the whole sample size is 1000 and we are making blocks of 10 is, so how many blocks will be made? Can you answer it in the chat box? Yes, that is 100. So now you understand. So we will make 100. Okay. So 100 blocks. So if you even analyze it in 300 population also. So in 300, you will have at least 50%, not if not 50%, then 48%, 52%, not much variability will be there among the sample size between the two groups at any stage. Okay. It will not be like 100 and 300, but it can be 140, 160. Maximum difference is that. So here comes that it remains comparable at each stage. So next slide. So what are the low risk, that is allocation concealment method? Okay, so that is central allocation, like that can be phone, web, pharmacy, sequentially numbered, sealed, opaque envelopes. Like envelope, which are sequentially numbered. We don't know what is there inside. Okay, so why sequentially numbered? So the patient number 1, then on those, so then that is sequentially numbered, then sealed, then opaque. Why opaque? Because in history there is evidence that even people used X-ray to see what was there in the inside your envelope. Okay, to avoid that also we use sealed opaque envelopes. Okay, so sequentially numbered identical drug containers for this is for parenteral preparations. So what are the high risk predictable risk predictable your, so that is random sequence known to stuff in advance. People know the random sequence. Okay, so then comes that is a high risk bias. Then envelopes or packaging without all safeguards. So you can go into literature. What are the different safeguards? Okay, so non-random predictable sequence. So these are high risk of bias. Okay, so next slide. So next is performance bias. If I know who is in the intervention arm and who is in the control arm, that what can happen, I will excessively care the intervention arm. I know that they are getting the new treatment, they are at risk. Okay, so what I will do, I will care more. So the treatment effect that is that you have evaluated, that may not reflect the your treatment effect, rather they may reflect a care effect also, that they are pura proper follow up mein hai, rather the control group is not well followed up. Okay, they are given all the small things, all other caring factors. So that induces a very strict bias, because many times physician follow up is also important. Okay, next slide. So avoids performance bias, different treatment in the intervention groups. So they may treat the different intervention group differently, different participant expectations. So participations will have different expectations, lead to changes in the actual outcome. Assess carefully, avoid term like single blinding, double blinding. If the research study says that this is a single blind, this is a double blind, this is a triple blind, don't believe in that. Blinding written, it is written that the study is blinded. That does not mean that the study is blinded. You have to assess carefully who was blinded, was blinding adequate. Okay, in one of the RCTs, I found that the same person, he did randomization, he did allocation concealment, he did your blinding, and that got published in PubMed, the index journals. So you have to be very careful in assessing risk of bias. Next slide. So writing a study is blinded does not mean it is blinded. Blinding, so which is low risk of blinding? So blinding, and unlikely that blinding could have been broken. So many times in Zidovudin trials specifically, what happened? The population, they went, the control population, the placebo population, the Zidovudin population, they got the benefit, they had health improvements. So they sold their medication to the placebo group. Okay, they knew that they were not getting the placebo group. So many times accidental unblinding can occur during the treatment. That may be from the side effect, that may be from the treatment effect. So you have to think very critically while assessing risk of bias. So no blinding or incomplete blinding, but outcome is unlikely to be influenced. Okay, there is no blinding or incomplete blinding, but the outcome is unlikely to be influenced. In that case also it is a low risk. And what is high risk? No blinding, incomplete or broken blinding, and outcome likely to be influenced. Okay. So next is detection bias. So that is basically your detection. So the blinding of outcome assessment. So means who is the outcome assessor and how was he blinded? Okay, so that is blinding of the outcome assessor. Next slide. So so this is part of detection bias, avoids detection bias. Measurement of the outcome affected by knowledge of the intervention received. So avoid carefully. I already told you, like single blinding or double blinding, that should be, don't believe in those terms. Rather, you evaluate yourself, and remember that participants, in many times the participants or personnel, they are also outcome assessors. Next slide. Next slide. So assessing blinding by outcome. So what is there? You have to do risk of bias for all of this. It is not that that whole study you will do only single risk of bias analysis. It is not like that. But rather you have to do risk of bias for every outcome or every outcome you are analyzing. So because in one outcome like death, that may have less impact on like blinding or unblinding, so that may impact, but a subjective outcome that may have more that may be more affected by your blinding and all. So you have to be very careful, and the risk of bias should be done on each of the outcomes that you are evaluating. Next slide. So So attrition, now incomplete outcome data. So many times what happens, like in the protocol, because for this evaluation of this, we use the protocol. You can in the clinical trial or in the published clinical trial report, you can see always the clinicaltrials.gov number is there, NCT number, or the CTRI number is there. The CTRI number, that is for Indian studies. So CTRI number you can see, and your CTRI number you can see, and you can assess. So from CTRI number, what was the sample size, and what was your that all those kind of data you can record for attrition. Actually, basically how many were randomized. Okay, so how many were randomized and how many were finally analyzed? Was there a significant missing data? Okay, next slide. So was there a significant missing data? Like many times there is significant missing data, and is the missing data by a balance between the two groups? If there is imbalance in the missing data between the two groups and the amount of missing data is too high, then there comes a high risk of bias in the study. So when complete outcome data for all is not available for your review, attritions, that is loss of follow-up, withdrawals or other missing data, and exclusions, so some individual will be excluded because of some criteria, predefined criteria, like withdrawal criteria is there. So those reports are not may not be included, so can lead to attrition bias. Okay, so what should you consider? How much data is missing from each group? Include numbers in your description. Why is it missing, and how were the data analyzed? Next slide. So there is no simple rule like taking 10% as your like many times they say that is 10%, many say that is 20%, but there is no simple rule. So it should be enough missing to meaningfully affect the result. Overall proportion of missing result, you should take event risk, dichotomous outcome, and plausible effect size. Okay, so results related to study outcomes may be recovered or adverse effects or refusal. So you have to you can go into more details about key how much is there, how much is the missing data. Generally we take 10 to 20% as a cutoff, or as a like there is, but there is no cutoff like this 10 to 20%, but that depends upon case to case basis. Next slide. So most important part is the missing data balance between the two groups. That is very, very important. So what is low risk? No missing data. Reason for missing data is not related to outcome. That is very, very important. That the missing data is not related to outcome. Missing data is balanced across the groups. Regions are similar. So that is low risk. Proportion missing or plausible effect size not enough to have a clinically relevant effect. So the missing data that is not sufficient to make a clinically relevant effect. So that is very, very important. Those are comes under low risk. High risk is regions related to outcome or imbalance in the number or regions. Proportion of missing or plausible effect size enough to have a clinically relevant effect. Okay, so then as treated analysis, the inappropriate use of imputation. So those are another points. Next slide. So reporting. So for reporting, we need to see the published protocol, and from published protocol, what were the objectives or what were the outcomes that were supposed to be reported, and in the final report that is published paper, what are the points that are reported? What is the difference between these two? Is there any difference? Or there may be, if there is any difference, then we can expect that the results are your published or the results are incorporated in a data-driven analysis manner. Means the person who has done the analysis has done multiple analysis, and from where the significance has come, he has reported those. So all those kind of things we have to take care of. Next slide. So low risk. So selective reporting, low risk is protocol is available and all pre-specified outcomes of interest to the review reported in the pre-specified way. So that is very, very important. Protocol is not available, but it is clear that all pre-specified and expected outcomes of interest are reported. So clinically important or those outcomes are reported. So unclear risk, that is most study will be just in this report. High risk is outcomes not reported as pre-specified or expected, like missing, added, subsets, etc. So outcomes reported incomplete, so that cannot be entered in a meta-analysis. Okay, next. So other source of bias. So there is last point is other source of bias. So here you can see study appears to be free of other source of risk. Okay, like when it is high risk, like issues specific to study design that can be carryover effect, because in crossover trials what happens is the period, that is the period between the two intervention. So two intervention, that is your not enough to get the drug eliminated almost near completely. So in that case, your what can happen is carryover effect can happen. Means drug A, effect of drug A may be carried over. That can be due to kinetic manner, or that can be due to dynamic manner, because many times you can see after treatment also you get the benefit to certain extent of time. So you have to take care of both. So carryover effect that can lead to your high risk, and recruitment bias in cluster randomized trials, non-randomized studies, baseline imbalance. So baseline, whenever there is a baseline imbalance, okay, so reporting bias, no, reporting bias and publication bias is different. Publication bias we will see, we make funnel plot like this. Okay, so funnel plot like this. So study should be equally distributed in both sides of the funnel. So baseline imbalance that indirectly indicates your there may be randomization may be improper. So in randomization, actually one of the point is whether baseline is balanced or not. Okay, so different diagnostic activity and other bias. Okay, so another point is there below baseline imbalance, block randomization in unblinded trial. Why this point is there? Why this point is there? So can anyone answer in the chat box? Block randomization in unblinded trial. Why it is high risk? Can anyone answer this in the chat box? Can you see the point in the high risk of bias from below? Third point, blocked randomization in unblinded trials. C. Okay, researcher will be knowing the allocation to treatment in the. Yes. So the last person, like you are doing, that is block randomization in the 1000 population, 1000 sample size trial. Let it be, we are enrolling the first 10. Okay. So for first 10, we know that there is 5 treatment A, 5 treatment B. So till each patient, what treatment is there? Let it be 5 treatment A and 3 treatment B already covered. So what will be the last 2? Can you tell me? In a single block, because our block size was 10. So till each patient or each participant, there was 5A and 3B. So what will be the last 2 participant? Can anyone message in the chat box? Yes, that will be B. So we can predict now. Okay. So we can predict the last sequences. So block randomization in an unblinded trial, it is many times it is predictable for the last few sequences. Next slide. So ultimately, risk of bias tables, we have to make one for each included study, and your judgment can be low risk, high risk, unclear. Okay. So support for judgment. Next slide. So support for judgment, direct quotes. Here you can see high risk. There is a written as a quote. In the randomized sequence generation, there is written as quote. This is a screenshot from Rebman. Okay. So in Rebman also you can do risk of bias, but I will show you ROB2 tool. Okay. So high risk of bias, there is a quote. Then in the quote meaning that the line is directly copied from the study. Okay. So on that basis of that line, you have included that article, you have assessed that article as a high risk of bias. In the elevation concealment, so there is a comment. What does it mean? So you have actually commented that this is the reason why I am putting it into the high risk. Okay. So in every, you have to actually define why you have included that study in the specific category. If you write code, then you write it in between the two commas. Okay. Okay. Next slide. So this is the risk of bias summary in the Rebman. You can see the question, yellow and question, that is unclear. Green is low risk and red is high risk. And on the top, there are different domains I already discussed: randomization, sequence generation, allocation concealment, then blinding of outcome. So all those were like, this is the final outcome. Next. So this is the overall risk of bias, overall among all the studies. So these the red are the unclear, yellow is, red is the high risk, yellow is unclear, and green is low risk of bias. Next slide. So these are earlier ways where they did your randomization or quality assessment of the studies. Next slide. So the quality assessment can be done in for your cohort studies or observation studies, even case reports, even your other form of studies also. There are different criteria or different algorithms or scales for using different studies in your meta-analysis, like Newcastle aqua scale. That is here we have showed that is in Newcastle aqua there is a overall for all observation studies, but there are specific scales for or specific subsets for your cohort studies, then case control, then cross-sectional studies also. That is available. You can get freely downloadable from Ottawa University so website. You can see. So here in the cohort study selection, though basically they emphasis upon three, three domains, that is selection. So is the study, that is representativeness of the exposed cohort. So how much it is representative of the exposed cohort? So because we know exposure and outcome, that is a very important integral part of a definition of cohort study, case control study, and cross-section study. Okay. So representativeness of exposed cohort, that is very important. Selection of a non-exposed cohort, because cases and control. So control should be same to the cases except the exposure of interest. Is it there, or there are some other lots, many other factors are they are affecting the outcome? So ascertainment of exposure, how the exposure was ascertained. Demonstration that outcome of interest was not present at the start of the study, means in initiation of the study or starting of the study the outcome of presence are not there. Then subsequently they followed up and ultimately the outcome happened or not happened in some. Okay. So comparability. Comparable the course on the basis of design and analysis. Then outcome, assessment of outcome was follow up long enough for outcomes to occur. Let it be we are doing a observation study or cohort study of your that is early phase of your Alzheimer's disease. So in that case, what happened? Many may not develop your overt Alzheimer's disease because that takes a long period or long time. So was the follow-up long enough for outcomes to occur? adequacy of follow-up of cohorts. So that is very, very important, and you have to evaluate it critically. Next slide. So these are the questions. So here you will put some stars, on based upon the stars you will say that the study is of high quality, study of low quality. So so here selection bias, like I have just, this is an example. So modified Newcastle Ottawa quality assessment scale for cohort studies. Selection for the cohort or subgroup that was intended or context. Did the study include a representative sample? Yes, no, unclear. So then were the exposed and non-exposed individuals drawn from the same source population? Okay. So here the case was TB. So that is IgRA interferon gamma release assay, positive, negative. So in the same population, because this is a diagnostic test accuracy. So the preferably the both should be done in the same population. Okay. Then determination of the index test. So how it is? So they have modified actually the cohort study for their study needs, because index test, that is a for diagnostic test, your accuracy study. So how to do risk of bias? So this is a part of risk of bias of the observational study. The Newcastle Ottawa scale I am telling, that is actually you can search in the net that what is Newcastle Ottawa scale. Okay, Robbins I scale is there, that is for non-randomized study. So observational study, the Newcastle Ottawa scale is there. So you can go through the net and you will have the PDF of the scales. You can use that. Next slide. So case control study. So selection, is the case definition adequate? Is it representativeness of the cases? Okay. So recently I went to your non-union of bone, one meta-analysis of non-union of bone. So defining non-union of bone was very, very problematic, because many do at 9 months, many do at 3 months. Many do by X-ray criteria, many do by clinical. That for clinical, this it is not happening, or this clinical criteria is not there, then that is non-union. So, and somebody said that if the physician is saying that there is no non-union, or it is unlikely to get united as per his clinical experience, then that is non-union. Okay, so you will get heterogeneous definitions. So how we can address this issue? We can incorporate that this definition of your non-union will include, and will exclude those by other definition, or you can do a subgroup analysis based upon the definition, that outcome definition, as per the outcome definition. So you can do, and you can see what is how the you can explain the heterogeneity, because in meta-analysis what happens, pooling the result is not enough. Explaining the heterogeneity, if you can explain the heterogeneity, that is the most important, one of the most important thing, because if the heterogeneity is, let it be 60%, more than 70%, then actually there is no, means you may pull, you may not pull the data, or if it is more than 80-90%, then you may not pull the data even. But if you can explain the heterogeneity, that what is the cause of that heterogeneity, then it gives you added advantage in publication of the meta-analysis. So selection of controls, then definition of controls. So control definition, that is very, very important, that how you have defined the control, how they have defined the control. Then comparability of cases and controls. Then exposure, ascertainment of exposure. Then same method of ascertainment for cases and controls. So that should be like, it should not happen like in cases the method was different, in the control the method was different, then that becomes an additional source of heterogeneity in the included studies. Then non-response rate. Okay, next slide. So initiatives to improve and reporting quality. So how the reporting, because many a times what you do, if you see studies conducted in earlier years like 1980s, 1970s, you will have very limited information. So because there was very less your reporting guidelines or something like that, so the articles are reported by as they thought it was perfect, or as per their convenience. But now we have different your reporting guidelines are there. You can go to strobe.org, STROBE, strobe.org. So there you will get many different your guidelines specifically for reporting of different types of study, like consort, okay, STRAD, that is reporting of diagnostic studies, PRISMA, reporting of systematic review and meta-analysis, okay, STROBE, that is reporting of observational study, STROBE guideline, whenever you do a observational study, you have to follow the STROBE. Then MOOS, reporting of meta-analysis of observational study. For observational study, you can specifically refer to this guideline. Then MSTAR, that is assessing quality of systematic reviews. If you have done a quality systematic review, how your review has performed, that can be evaluated by MSTAR. So was a priori design provided? Okay, so this is some of the questions. So was a priori design provided? Like in case of similar to your randomized control trial, where we have to publish the protocol in CTRI or in clinicaltrials.gov. The same thing we need to do in your meta-analysis also. We have to do the protocol publication in that is Prospero. Then subsequently we have to do the meta-analysis process. Was there a duplicate study selection and data extraction? So the meta-analysis, that is rigorous methodology, is to be followed. Each thing should be done by a minimum of 2 reviewers. So was there minimum duplicate study selection and data extraction? Was that there? Was a comprehensive literature search performed? So you have to see how was their search strategy. Okay, because understanding the search strategy is one of the early and one of the key factors of success of a meta-analysis. If you miss too many studies, then you may not get the true effect in the population. So was a comprehensive literature search performed? Was the status of publication, like gray literature, used as inclusion criteria? So was the list of studies provided included and excluded? See, we give reason of only included studies, but here they are saying that list of excluded studies provided. Was there characteristics of included studies provided? So basically PICO, that is population, intervention, comparator, and outcome. So all those characteristics were those provided, and you might add actually additional characteristics depending upon your study or study requirements. Next slide. Was the scientific quality of the included studies assessed and documented? Okay, then from, like, you say it a high risk of bias, but you should have enough information to say that this is a high risk of bias. If it is unclear, then that's fine. If it is low risk of bias, then you should have enough justification for whatever decision you make. Was the scientific quality of the included studies used appropriately for formulating conclusions? Okay, we have done a meta-analysis on serum ferritin in COVID-19. So after the meta-regression analysis and all, we found that even male gender also has higher ferritin. Patient with diabetes have higher ferritin. Patient with other forms have higher ferritin. And all those groups in whom serum ferritin was evaluated, there was imbalance in gender, there was imbalance in your diabetes and other comorbid conditions. So we have to give a conclusion that serum ferritin can be an important marker, but it has to be interpreted cautiously by taking care of all these factors. Okay, so that is very, very important. Was the scientific quality of the included studies used appropriately in formulating conclusions? Were the methods used to combine finding of study appropriate? Like, let it be, you have done a meta-analysis on some mean differences. Okay, and what happened? In one, the scale was in some different. In another study, the scale was different. But you have just pulled in a mean difference. So that may not be appropriate. Okay. So you have to do weighted mean difference or other kind of studies, other kind of analysis. So that was the study methods to combine the findings were appropriate. That is very, very important. Was the likelihood of publication bias assessed? So funnel plot, and you will need minimum 10 studies, or so was the funnel plot, that is likelihood of publication bias assessed? Conflict of interest included. So many a times what happen, conflict of interest that has significant impact on like strength of recommendation, because studies with conflict of interest versus studies without conflict of interest, there may be significant variation. And indeed, research has shown that there is significant variation in the effect size between these two types of studies. Those with some government funding, those with industry sponsored funding. So we have to think critically, we have to do carefully reasoning so that we can go for this. Next slide. So take home studies. Bias studies may lead to misleading reviews. 7 domains, so this is for randomized control trials, 7 domains of bias to be assessed. Describe what happened in detail and give your judgment. Consider the possible effects and use appropriate caution in interpreting your results. So thank you. Now I will want to show the Rob2 tool. Can I share now?
Sure, sir, you can share.
Or I am sending it to you only. Just wait 1 minute.
Sure, sir.
Mhm. Can you please? Oh, okay, that's fine. Dr. Jitendra, I have sent it to you in mail.
So give us a 1 minute. We'll just open it up.
Please share the take home message. Okay, ma'am, please share the take home message slide once.
Sure, sir. I hope it is visible.
Yes. Can you go to the Redmond that is discovered by slide? One was there, na? One was there with quote and all.
I'll just go to sir.
Please go back. Yeah, yes, that one. No. Next. Next.
This one, sir.
No. Next. One. Next. Let me check. Ma'am, slide number 47.
Okay, sir. I'll go to that. Yes, sir, it is there.
So this is how you look in Redmond. Okay. So this is how you look in Redmond. If you do it high risk, then again unclear risk or you are giving low risk, then you don't write anything, the color will not come. Okay, the specific color that green or red or your red will come, but other color or unclear that will not come. So you have to write something, you have to give some justification, then the specific color coding will come in the final format. Okay, now please do the risk of bias so that Rob to tool. Those colors are given by, that is standardized color, that is given by Rebman. So that the colors remain homogeneous, and that is easily, it's like red is for high risk, yellow is for unclear, and green is for low risk.
Sir, I'm just sharing my screen now.
Okay. So here you can see this is the Rob2 tool. Now you can download from internet also. Okay. Download it from internet also. Then this is Excel sheet. Okay. Then now come to Rob2 assessment form. Click on the Rob2 assessment form. No, above. Manual. Yes, just click on here.
I'm just
Then
enabling it.
allow editing.
Yes,
Do
sir.
allow editing. Enable content. Enable content. Enable
Yes, sir.
content. Yes. Now click on this. So this is the form it will look like. So you put assessment ID, then who is the assessor? Okay. Study ID, then any reference or label, then experimental comparator, what is the treatments, specify which outcome. See, I told you that and in the same study there will be different outcomes. Okay. So this is basically outcome based your evaluation. Which outcome? Okay. Then is the review team aim for the result to assess? So wait for analysis. What is wait for analysis? In the meta-analysis, you can see there is a wait in the that is forest plot. You always see one thing is weight or weight of the study in the final result. Okay. So what is the importance of that? That your on the study on the final your uh, outcome or final effect size. So that is mentioned by the weight of the analysis. So you have to put that there so that it will your incorporate that also in the risk of bias analysis. Then domain 1. So was the allocation sequence random? Then in the response, can you click, ma'am? In the response,
Yes.
you please click 1.1. 1.1 above. No. In the domain 1 randomization process, then signaling first question. No, below what? 2 line below. Yes.
Yes.
Was yes. Just click yes. Click there. So yes, possibly yes. No. Just click. Just click. Keep. Don't put anything. Don't put anything. Possibly yes.
Okay, sir.
Possibly no. No, and no information. So these are the things. If you read the guideline of the your ROB2, you will come to know when you have to put yes, when you have to put no. All these points are specifically mentioned in the guideline. Was the allocation sequence random? So I have already also told you which are low risk, which are high risk. Okay. So depending upon that, you can put the response. Then, okay, now put yes only. Then was the allocation sequence concealed until participants were enrolled and assigned to intervention? There also possibly yes, you may do possibly yes. Possibly yes, PY. Okay. Did baseline difference between the intervention group suggest a problem? So what I told you, if there is any difference in the baseline about important your characteristics of the study or participants, so the NI stand for no information. Okay. Did the baseline study between intervention groups suggest a problem with the randomization process? So if there is an imbalance, then that may indicate a process in the your process in the randomization, imbalance in the problem in the randomization process. So let it keep it as possibly no, just like that. So like this domain 2 you click, and here in the description you may give quotes or something like that in the domain 2. Okay, so signaling questions that are not coming, maybe your security, but that is computer security has hampered that. Domain 3, the similar kind of questions will come. Now click on domain 3. Yes. So where the data from the outcome available for all or nearly all participants randomized. So jitna participant ka randomized hua tha, all data is outcome available, possibly no or no. Let it keep as no. No. Okay, then description, you have to give the description. Okay, then if no, possibly no, no, two, three, is there any evidence that result was not biased by the missing outcome data? So 3.1 में अगर ये no, possibly no or no information हुआ, so after that you will evaluate, is there evidence that the results were not biased by the missing outcome data? So yes, let it make it as yes. So could missingness be outcome depend on the true value? So here now it is no, not relevant, but you make it you convert y to your no. So now could missingness be in the outcome depend on the true value? So you can sense like this. Okay. So now risk of bias. So like domain 5 you can click. Keep the second yes only. Okay. In the domain 4, keep the second yes only.
Sir, this one?
नहीं वो domain 3 था, not domain 4.
This we have done. So I'll be doing this.
Yeah. Keep it as yes. Okay. So
Okay.
then domain 4. Was the method of measurement of outcome appropriate? So outcome measurement method, that is very, very important. Could the measurement of ascertainment of the outcome have differed between intervention groups? So possibly no. P N कर दो. Okay. Then come to domain 5. So where the data that produced this result analyzed in accordance with the pre-specific analysis plan that was finalized before the unblinded outcome data were available for the analysis. So means outcome plan के हिसाब से analysis किया कि नहीं. प्रोटोकॉल में जो आउटकम प्लान उन लोगों ने सीटीआरआई में या कहीं पे भी लिखा हुआ है कि ये प्रोटोकॉल है हमारा, ये दैट इज यू कैन सी द प्रोटोकॉल इन सीटीआरआई और clinicaltrials.gov. उसमें जो लिखा हुआ आउटकम है वही एनालिसिस किया है कि दूसरा एनालिसिस किया है, इसमें लिख दो यस लिख दो, जस्ट लेट इट बी दे हैव डन इट एज पर दैट. ओके. देन मल्टीपल एलिजिबल आउटकम मेजरमेंट्स स्केल डिफरेंसेस विद इन द सेम आउटकम डोमेन. सो नो कर दो इसको. So now overall bias. Come to overall bias. So here you can see there is a algorithm and assessor's judgment. What is that? In the algorithm you can click. In the algorithm you can click.
I have
Okay.
clicked
So
that one.
what happens that actually we have not done all actually na. So the algorithm result is not giving, but we can put from assessor judgment that overall if there is any high risk of domain in one, then we will put it in the high risk of domains. Okay. Okay. So method of analysis we can put if it is intention to treat analysis. Okay. But many a times what happens if you input it also, imputation can be very dangerous. So we have to take care of it. So this is um, um, a very brief overview of your ROB2. So you can do as per that. So any questions? We need to fill all points. Yes, we need to fill all points. Yes. We need to fill all point always.
Thank you very much for your enlightening talk, sir. It was really beneficial for all the participants connected here. And I suppose you have also addressed all the queries side by side from the participants.
Okay, slides are not moving. Okay. So Ryan software we cannot use for risk of bias.
So we have one more recent query now. The articles included in pilot testing can be included in the main review.
What? Yeah, we can do, ma'am. In the pilot testing can be, ma'am, whatever means like you can always put things in the supplementary file.
And one more query is there, what to do with the table?
With this table means the ROB2, you are telling about the ROB2, Dr. Nilesh. So Newcastle auto scale, I have already told you, Newcastle auto scale that is used for risk of bias analysis in the observational study. So in that case, what happens? We will do your like risk of bias for all the studies, and now depending upon the number of stars. I have showed you that against each question there are some stars are there. So depending upon the number of stars, like less than 3, 3 to 6, more than 6, so the study will be evaluated for quality assessment.
Thank you very much, sir. I think you have addressed all the queries from the participants, and it was a very enlightening session for all of us. We are very thankful to have you today with us, sir.
Thank you, ma'am. Thank you. Thank you, everyone.
So with this, we'll try to move to the second session of the day. And for this, we have with us Dr. Sushma Kumari Seni, and I'll take privilege to introduce her to all the audience in this workshop. Dr. Seni is a seasoned nursing professional with an illustrious career spanning over 37 years, rooted in the academic excellence and dedicated service. She completed her graduation in 1985 with post-graduation in 1992 from the College of Nursing, PGI-MER, Chandigarh, and earned her PhD from Punjab University, Chandigarh in 2006. Currently a faculty member at National Institute of Nursing Education, PGI-MER, Chandigarh, she is a prolific contributor to the field with 123 publications in reputed journals, a H-index of 10, and 326 citations. As a passionate advocate for nursing research, she serves as the Secretary of SOFIA, Chapter Secretary of SWAMI's Chandigarh State Branch, and Vice President of Nursing Research Forum. She is also the joint editor of the Nursing and Midwifery Research Journal and a member of editorial boards for multiple reputed journals. Dr. Seni has authored 3 books, edited 1, and contributed chapters to numerous others with a special interest in reproductive and child health. She has guided PhD students and PGI-MER and the INC consortium and mentored international nursing students at Walden University, USA. Her leadership extended to being project director for the Composite Target Intervention Project in collaboration with the State AIDS Control Society, Chandigarh, for a decade. As an accomplished academician and researcher, she has presented at local, national, and international conferences, earning recognition such as Outstanding Scientist Award at the International Scientist Awards 2020 by VDG-OOD Professional Association. In today's session, ma'am will deliver her expertise on evidence-based practice for SRMA. We are honored to have you among us today, ma'am. Over to you.
Hello, good evening. Good evening, everyone. So must be delighted to have a very good session. Just now we are able to finish with lot of queries and very good explanation. So let me share the slide. Is the slide visible? Hello?
Yes, ma'am, it is visible.
Can I start now?
Sure, ma'am, you can start.
Okay. So good evening, everyone. So today I'll be discussing about evidence-based practice, because we had been discussing what is systematic review and how it is to be done. And now we will discuss that how it will be practiced. So just talking about the evidence. Evidence is something that furnishes testimony or something legally submitted to a certain in the truth of matter. And evidence-based practice is the systematic interconnecting of scientifically generated evidences with tacit knowledge of expert practitioners to achieve a change in a particular practice for benefit of well-defined client and patient group. This definition was given in French 1999. And why this evidence-based practice is important? Because we have been discussing it since last 7 days, but why it is important? Because the quality problem occur even if in the hands of dedicated, conscious professional, still they find sometimes that the quality is important. And the burden of harm from underuse, misuse, and overuse of care is very staggering because it can happen. So for that reason, this is important that we should have evidence-based practice. In 2003 report of Institute Medical Health Professional Education, A Bridge to Quality, they recommended that all healthcare professionals possess certain skill and competence in order to enhance patient care quality and safety. So now let us start with what the evidence practice is. It is knowing what we do the best practice. And what is best practice? That has 3 components. What is the number one? What is the best available research evidences that we can get it from the literature, different research which is available, which is published by various good researchers. And the second is the clinical expertise, because apart from the evidences which are available in the literature, we do have the clinical expertise. So we have to mix those evidences with the clinical expertise. And then the third component, that is the most important component, what patient wants. What are her values, what the choices, preferences, isn't it? So all those mix up of all these things, we are able to make the clinical decisions based on evidence-based practice. Isn't it? So we talk of lot of research every day, lot of research has been conducted, but everything is not applied in practice. That's what we call research practice gap, isn't it? So research practice gap, even though the guideline and the knowledge have been disseminated, you have published the research, but overall effect on clinical practice and their outcome on clinical practice is not unclear. That's what we that's what we say, that this is the research practice gap, isn't it? So during 1980 and 1990, the nursing emphasized bridging this research practice gap through the development of research utilization projects. And what these research utilization projects are, these are they are certain steps of research utilization, which include dissemination of knowledge, synthesis of finding, critiques of studies, application of finding, and development of research-based practical guidelines to practice. So that is the research utilization project. And what evidence-based practice is, it is strengthening the evidence base so that we know that what work and what does not work in providing patient with best outcome. And then standardizing these evidence across the field to reach the best evidence to the patient, and housing evidence in the online data, providing reviews of evidence base, and then translating and consolidating the state of science into clinical recommendations. And how far these two are different. Research utilization is, you have the research findings on some topics, you evaluate, integrate those findings, and then you use it in practice by producing the guideline. That is research utilization. But evidence-based practice is a little more than that. We have the search for best evidences to address clinical problem. Then we evaluate and integrate the findings to get the best evidence. Then we mix these evidences with our clinical expertise and go for the practice looking into the patient preferences, our clinical expertise, and mixing both together with the evidences. Then we use this for the practice so that we can give best evidences or practice best evidences for the patient care. So this evidence base is a newer complex process It includes a system to grade or level of quality of research. It includes evaluation of cost, patient preferences, and staff expertise. And research utilization, it is less complex, older concept, no defined system to evaluate research, and does not include the evaluation of cost, patient preference, and your staff or clinical expertise. So the evidence-based practice, as we discussed earlier, it has three major components. That is the best evidences, which you get from the different studies which are published in the literature. Then patients' values, what are their needs, what according to their gender, according to their culture, socioeconomic status, and even their choice, their psychology, isn't it? And their spiritual values. So all that together, what they want. And then your clinical expertise, like what clinical expertise you have, how many patients you are you are seeing every day or practicing with those patients every day, and how much skill do you have. And based, when mix all these three things together, so that becomes the evidence-based practice. So that these three components, research evidences, clinical expertise, patient values, and the fourth things now they have added, that is the circumstances, the environment where do you practice all this. So it is using the best available current evidences, patient values, clinical expertise, and environment and organizational context. Because ultimately you have to practice it in some environment or in some organization. So the clinical decisions have to be made according to that environment or the policies of the institute. So there are 7 steps for the evidence-based practice. That is cultivate spirit of inquiry, 0 step. Then 1 is the ask questions in PICOT format, search for best evidence, critically appraise the evidence for the applicability, integrate the evidence with clinical expertise and patient preference value, and evaluate the change resulting from implementing the evidence and in practice, and disseminate the evidence-based results. So this is the process. This again, similar steps only: asking the clinical question, collecting related evidence, critically appraisal of evidence, integrate the evidence, evaluate the outcome, and disseminate the outcome. Isn't it? So that's the same thing, but asked in a different way. So let us see one by one. So the first step is the asking a searchable, answerable questions. That is the first step to accomplish the goal. So you have to look for the question you want to search. So there can be 2 types of questions. First is the background question, and for which the who, what, where, when, how, and why. And second is the foreground question. Ask for specific knowledge to inform the clinical decisions. So you have to ask this question in PICOT form. So we are from day 1 onwards, we have been discussing it. We know the full format: the P is for patient, population or problem, I is for intervention, C for comparison, outcome, and then time. Isn't it? So let's have an example. What is the duration of recovery of patient who have gone through total hip replacement, who developed post-operative infection, as opposed to that who did not, during the first 6 weeks of recovery? So here the P is for the patient who have gone through total hip replacement, I is who developed post-operative infections, and C is the comparison group who did not, and O is the duration of recovery, and T is like first 6 weeks of recovery. So time is 6 weeks. So once you have asked a question in the PICOT format, the second exercise is assembling the evidences. So assembling the evidences through literature. So we have the research-based evidence sites, and you had a very beautiful presentation and demonstration how to look for the literature and how to collect evidences. So we have these sites in HAL, Medline database, Cochrane library, PubMed, Embase, Cycloinfo, Dynamed, Scopus, and many more, isn't it? So you had a beautiful demonstration on it. Then critically appraising the evidence. In determining the implementation potential of innovation in particular setting, several problems can occur. So you have to see the cost benefit ratio. Like if the cost is more, benefit is lesser, then it is not good. If with low cost and better benefits, it is always preferred. So questions you have to say for the appraising the evidences. For here also you had a beautiful class how to appraise the evidences. So what is the quality of evidence? How reliable it is? What is the evidence? That is how powerful the effects are. How precise the effects are. Is there any side effect? What are the financial cost of applying the evidences? And is the evidence relevant to my particular clinical situation? And then once you have evaluated the evidences, then you need to integrate it. So research evidence need to be integrated with other types of information, including your own clinical expertise, knowledge of your clinical setting, and patient preferences. And then ultimately you have to implement the evidences and evaluate the outcomes. So evaluating in terms of how the innovation was received, to what extent the guidelines were followed, what implementation problems were encountered, and outcome in terms of client's outcome and cost effectiveness. The end result could be the conclusions about whether to adopt the innovation or to modify and go back for the precise practice. Because once not there that you have generated some evidences, they will be always good. Sometimes they do not get in some setting they are not very practical. It may be very good for the other setting. Then if it is so, then you have to modify it according to your setting. And then you disseminate, that is the final step, that is benefit, so that whatever you got, it may be beneficial for other practitioner. So disseminate the result. That can be done through conferences or publishing in the good journal. So ultimately, these are the 5 questions. Ask a very good question, then it, and whatever your problem is, convert into the question into its question. Acquire, that is you get the evidences from the literature. Appraise, that is critical appraisal. Apply, that is integrate the evidences with your clinical decision making. And then audit. Audit means you evaluate all the 4 steps, and then you see that if the improvement is needed or it can be applied as such. So these are again the steps of evidence-based practice. You have to develop a well-built question, find evidences, evaluate the strength, apply evidence, and evaluate. So you are all aware of this hierarchy of evidences. So this shows you that how you get the best evidences. Based on this picture, you say that there are 2 types of evidence: strong evidences and weaker evidences. Strongest evidences are meta-analysis, integrative reviews, and experimental studies. That is RCT mainly. Weaker evidences are descriptive surveys, qualitative studies, correlational studies, and even quasi-experimental studies. So what are the aims of evidence-based practice? That is to provide a high quality and most cost-effective nursing care possible, to advance quality of care provided to healthcare workers, to increase satisfaction among patients, to focus on nursing practice away from habits and tradition to evidence and research. It results in better patient outcome. It contributes to science of nursing, because when you generate evidence, it adds to the literature, it adds to the body of knowledge. It keeps practice current and relevant. It increases confidence in decision making. And the objective and the purpose of evidence-based practice is that it seeks to replace the practice as usual. What we have been doing since years, it may get outdated as medical sciences. It's growing very fast, and to match with it, we need to change the rigorous practices, isn't it? So, that can be ideally through the randomized controlled trial. So it also seeks to make practice less subjective enterprise. and to rise to the higher level of accountability so that everyone can use it. Reduces the variations in nursing care and assist with efficiencies and effective decision making, providing practice to nurse evidence-based data to deliver the effective care. And need is for making sure that each client get best possible service, update knowledge, and that is essential for lifelong learning, provide clinical judgment, improve care provided, and save lives, to provide framework for understanding the evidence-based practice process. So there are three models which can be used for evidence-based practice. That is Stellar model, Iowa model, Roseworm and Lamabe model. So just have some glimpses of these models, how the evidences can be put into practice. Stettler model was developed as practitioner-oriented model in 1994. It was revised in 2001 without change and focus on critical care thinking. It raised awareness about the importance of applying research finding into nursing practice. The meaning of the meaning of evidence as per Statler model is like there are two different information or fact which is obtained systematically, could be from two different sources, external and internal evidences. So what is external evidence? That is derived from opinions of concept, comes from the expert's own experiences. And internal evidences that is come from systematically obtained fact or information at ground level. Isn't it? So this is the process how the Stettler model can be applied in first phase preparation, where you will look into the evidences and where you will find the evidences. The phase 2 is the validation of evidence. Phase 3 is comparative evaluation and decision making. Then translation, the application into practice, and then evaluation. So these are the steps of Stettler model. Iowa model that was successfully implementing since 1994. It infuses research into practice to improve quality of care. Maybe plan change principle, integrated research and practice, utilize the multidisciplinary team approach. The highlights of this model is it incorporates the use of research and other forms of evidences, and interferences of support research use might involve every level of organization, and evidence-based practices linked with quality assurance. Staff are given recognition for their research work. Clinicians are given time and resources for the research work. This model explains how organizations change the practice which is based on research. It gives a systemic design. It includes both practitioner and organization practice perspective. It provides guide for regarding implementation of evidence-based practice. So Iowa model, it has the problem focus triggered. That is risk management, data processes, improvement data, internal or external benchmarking data, financial data, and identification of clinical problems. The knowledge focus triggers new research or other literature, national agencies, guidelines, standard philosophy of care, question from institutional standard committee. So by focusing on the problem triggers and knowledge, this research is made into the practice. There is the Roseworm and Larry model. This was developed in 1999. It begins with assessment of need and integration of evidence-based protocol, focus on the use of change theory, principle of research, and standardization of nursing nomenclature. So the stages are assessment, need for change, link problem intervention and outcome, synthesis of best evidences, design practice change, implement the evaluation, change in practice, and integrate and maintain change in practice. So these are the steps of Roseworm and Larrabee model. There are few more models such as John Hopkins Nursing Evidence-Based Practice model, which talks about different factors like internal and external factors. Internal factors, culture, environment, equipment, supplies, staff, standards. External are accreditation, core measure, legislation, licensing standards. And they together they mix up with the research which is experimental, quasi-experimental, non-experimental or qualitative, and mix it with certain non-research method, that is the organizational experience, quality improvement, clinical expertise, patient preferences, then it is implemented into the organization. There is one more model, that is Grove model for implementation evidence-based practice. That is again, once you have face a practice problem, then you search for best evidences and look at the quality of evidence-based guidelines, and then you can prepare the guidelines which is to deal with the significance of health problem, strength of research evidence, linked to the national standards, look at the cost effectiveness, and then you can integrate these evidences into clinical mixing with the clinical expertise, and use the evidence-based guidelines for practice, which is as per the requirement of patient, providers, and healthcare agency. And once you have implement those guidelines, then evaluate the outcome from the use of evidence-based guidelines. And you can refine if you feel that there are some issues in implementing the guideline. And then after the refining, you can continue the evidence-based practice. So the advantages of this evidence-based practices provide better information to practitioners, enable consistency of care, better patient outcome, provide client-focused care, structured process. If you prepare a structure and accordingly, the people can work accordingly. Increases confidence in decision-making, generalize information, contribute to the literature and the knowledge base, provide guideline for further research, help nurses to provide high-quality patient care. Disadvantages, if you don't get enough evidences, it is very much time-consuming, reduce client choice, reduce professional judgment and autonomy, suppress creativity, influence legal proceedings, and it may have publication bias. And then there are certain barriers in evidence-based practice. One thing is we hardly value research. So much of research are conducted every year. They are just lying into the library. And even if it is published in the practice field, if you talk to the people about research, they hardly feel its importance. And it is very difficult to bring a change. People are so tuned to work in a routine, and if you tell them to change this, they just resist to it. Then administrative support you don't get. There may be a lack of knowledgeable mentors, and the seniors who are working there, they may not have that much knowledge. And there may be a lack of time for research, lack of knowledge about research. Research reports are not easily available, complexity of research reports, and lack of knowledge about evidences. So there are different barriers at administrative level. There is a lack of emphasis placed on research, limited resources to make changes, and previous changes not based on research. What has been done earlier, it may not be based on research. And factors to be considered when you are implementing change, that is time, support and resources needed, money, and institutional or other barriers. Like the institutional policies, it should not be it should be going according to the institution policy that you have to consider. And barriers at clinician or nurse level, they may have the lack of knowledge about research process, do not keep up to date with research, do not believe or trust the research finding, inability to implement finding into daily practice. And how these guidelines are developed, there are agencies for healthcare research and quality, which help with the guidelines through development of an expert panel. This group designates the scope of guideline. They synthesize the finding to develop recommendation and practice. And these guidelines which are developed are presented at the meetings and published. So these are the example of certain guidelines which are already developed by this group. That is pain management, acuity prediction, prevention, cataract treatment in adult, depression treatment, screening, diagnosis, management of sickle cell disease in newborns and infant, otitis media treatment in children, and availability of cardiac rehabilitation services. and there are many more. So there are other agencies also where you can find these guidelines. Agency for Health Care Research and Quality is there, which we have been discussing. National Guideline Clearinghouse, Academic Center for Evidence-Based Nursing, American College of Physicians, and American Academy of Pediatricians. And how this evidence-based practice is implemented into the real world, you have to identify the practice problem, search for best evidences, determine the quality of guideline by assessing author, significance of problem, strength of evidence, linked to the national standard and cost-effective guidelines. So sometimes this terminology also, sometimes we talk of translational research. So what the translational research is, it is an evolving concept defined by National Institute of Health as the translation of basic scientific discoveries into practical application, encouraged by nursing and medicine to increase the implementation of evidence-based intervention in practice and determine if these interventions are effective. So the benefit of evidence-based nursing practice, like there are fewer errors. You can reduce the likelihood of making type 1 and type 2 errors in practice. That is, type 1 error is accepting of practice that is incorrect. For example, administration of wrong dose using the wrong procedure, teaching patient using the wrong information. Type 2 rejection of practice that is correct. Failing to screen the patient for fall of pressure, ulcer risk, or for failing to wash hands before and after patient contact, failing to provide patient with smoking cessation information. So with the evidence-based nursing practice, you are able to reduce both kind of errors. And another benefit is greater professional satisfaction from working as a part of team and experiencing effective practice. And for the better care, that is less variation in care among caregivers. If you have evidences, the guidelines, so everyone will practice in a similar way. And more predictable health outcome. We know that if this guideline is to be practiced, this will be the patient outcome. You can predict. Less waste of inefficient yielding, fewer delays or diagnosing in treatment, and fewer complications because you have been given a standard guidelines. So thank you very much for patient listening.
Thank you very much, ma'am, for your valuable discussions on EPP, and it was definitely useful for all the participants. I request participants, if there are any queries, I think 1 or 2 we can take because we are already out of time. And ma'am can help you if you have anything to ask regarding the topic right now. You can post your queries in the chat box possibly. So I can see the comments right now, ma'am. They are well satisfied, and because you have explained everything very well. And I'm very thankful to you for explaining this important concept to all the researchers here, and it will be definitely useful for all of them. Ma'am, I'll also request you to please spare just a few minutes more for us,
Okay.
because we have some awards category for this particular workshop. And I'll just share my screen with all the participants, and I'll just take your valuable time to announce all the winners that we have from this particular workshop. And along with that, we'll be also launching one more workshop that is in the coming month. So for that also, I request you if you can update our participants